Hi guys, today we're going to pick up where we left off yesterday. So we're going to talk about the properties of waves. So we're going to focus on wavelength, frequency, wave speed, amplitude, and energy. So please make sure you have your notebook out and add these onto your notes from yesterday. So wavelength is the distance between a point on one wave and the same point on another wave. For example, from the top of each wave or crest to the next crest. So that would be one wavelength. Or trough to trough. So that would be another wavelength. So this picture down here, this arrow shows trough to trough. And they can be vary from being very big to very small. So frequency is the number of wavelengths that pass a point each second, and they're measured in hertz. So 1 hertz equals 1 wavelength per second. The longer the wavelength, the longer the frequency. Wave speed depends on the medium through which it travels. So electromagnetic waves can travel 300 million meters per second, so really, really fast, the speed of light. And mechanical waves travel slower because they are traveling through matter. Amplitude is the measure of the wave from its rest position. And the greater the amplitude, the greater amount of energy the waves have. So different waves carry different amounts of energy. Small amplitude, small amount of energy. Large amplitude, large amount of energy. Waves also interact with matter, and they interact with matter in 3 ways: transmission, reflection, and refraction. So transmission, so waves will transmit or carry energy through materials. For example, this person is talking into a microwave, and those waves are being transferred through transmitter, and we can hear them as it travels through matter, which is not as loud because the matter takes away some of the transmission. Some materials are also, waves will absorb materials. So some materials move through the materials and turn into thermal energy. So kind of like the sun will hit on the ground, and that ground then absorbs the thermal energy and will turn it into warmth. Reflection, so some waves will bounce back. So the energy bounces back or reflects, and this is easily seen in the mirror when our image reflects back at us. And the law of reflection says that a wave approaching the surface is our incident. So you can see this wave coming in, and the wave going off is reflected. So the law of reflection says that whatever the angle it's coming in, it will be reflected at the same angle. So the angle between the incident wave and the normal wave always equals the angle between the normal wave and the reflected. So they just said it very scientifically. What it means is whatever angle this is coming in, this is also going out at. Refraction is a change in the direction of a wave when it enters a medium. So for example, if you're looking at a fish tank, the fish will appear to be in different areas depending on which way you are looking in, because the light actually bends, and you get a bend because it's entering the water or a new medium. Diffraction is a change in direction when it travels past the edge of an object. So think of this like our classroom and the door. So you hear really loud in the classroom, and then as the sound exits the classroom, it will go in different directions, so that it just changes because of the barrier of the walls. Okay, that is where we are going to end today. I'm going to put a video on waves, so please, when you're done writing your notes, go watch the video, and then we will start working with these terms in our next assignments. All right, have a great day.